967 subscribers, Ros. Yeah. 967.
Yeah.
Seconds.
All right. Hello, welcome to this live session on physics, topic by topic. We're going to look at today some component characteristics, some electrical components. We're going to have a look at things like light bulbs. We're going to look at diodes, thermistors and photoelectric cells. So we'll get stuck into having a look at some of these things, and I'm going to have a look at it in two different ways. I've got two different kits and I can show you how they work together. So let's go over and have a look and see what it looks like. So I've got here all my boxes of electrical equipment, and they basically come in two types. I've either got a setup which looks like this, with basically batteries, crocodile clips and wires, and those are going to, with perhaps some meters, and we can connect these to larger electrical components such as things like bulbs, and look at things like little resistors like this, and with little sort of junction boxes. So this is one way of trying to do everything. Or the other way, looking at things like electronics, where we can actually build circuits up on this sort of circuit board. We can achieve exactly the same thing with both setups, but sometimes this looks easier because it's built round the sort of same format that a normal circuit is. And I've got other bits and pieces like my resistors here that I can play with. And we can also try and set much of this equipment up, and this is stuff called Pasco gear here, and what I can do with this is I can connect various bits and pieces to the computer, and I've got somewhere in here a voltmeter, and I've got an ammeter that we can use to connect things up, and it'll draw the graphs for us automatically. So I'm putting all that out the way for the time being, and we're going to start having a look at all this equipment using basic electrical components. And we could start to have a look and see what it does. And I'm going to look at it this way and see what happens. So let's start off with, we've got our battery. We can take 2 meters here. I've got this one which is set up as an ammeter, and I've got this one which is set up as a voltmeter. I can convert them very easily because these have got simple little dials, and we can turn the dial around to turn this into a voltmeter or an ammeter. And we've got some wires to set up so we can try and draw our circuits and be familiar with what they look like. I've got red wires, I've got black wires. The only difference between these is colour. We can set everything up in red, we can set everything up in black, and we can see how it goes. Right, let's have a look and see what we can do with some of this equipment here. I've got a simple switch. If I try and hold it down there, we simply press the switch down and it makes some contact. Right, let's have a look and see what we can do with some of this equipment. I've got a diode, LED, we've got a bulb to have a look at and see what they do. I've also got this idea of a universal clip, so I could clip any particular component that I want to have a look at in there. Let's have a look and see what we can do with a circuit. So let's build a circuit. When we design a circuit, we design it by drawing in the diagram accurately, and then we try and make this look realistic. So if I try and draw in an item, we might draw this in firstly then with a battery, a collection of cells. Then I ought to use a ruler. I'm not, because I'm trying to do this quickly. We can put in a closed switch. Let's then put in a bulb. We could put in then an ammeter and complete the circuit. Let's translate that into something, and then after I've done that, what I'm going to do is in parallel I'm going to put in a voltmeter. So that's my circuit I'm going to try and draw. Let's relate that to what we really see. I've brought my circuit over here because I want it for my basic plan, and let's see what we can do. I've got my battery. We're going to come out of my battery, and I can determine whether I want to do positive or negative. So we're going to do negative there, and let's just put a positive out of there. That's going to give me 3 volts, and my battery is then going to go to my switch. We'll take the positive side and go to the switch. From the switch I'm going to go to a light bulb. From my light bulb I want to now go to an ammeter. Of the 2, here we have this one. So I'm going to have a cable coming from my bulb and going to the ammeter. Now the ammeter has got 2 settings here. Paul's just going to try and zoom in on this. We've got the ammeter, and then we have a common. We've got the other one there for the voltmeter. Let's see what this one does. So let's go into the ammeter, and we go from the ammeter running out of room back to the battery. Let's switch on the ammeter. And I think I'm going to have no luck here. I might have a dead bulb. There we are. Wasn't in enough. There we are. There's my bulb lighting it up. Let's just verify that it worked there. That battery seems to be dead. I think I'm going to put these on a bit of recharge. So I will just use that setup. So I've got my ammeter set up with my batteries, and since they're not working at the moment, I'll take those out. There's my circuit. Now I want to put in a voltmeter. Put in the voltmeter on my circuit. This is now going across the bulb, so let's do that. I'm going to take one black and one red. This is the red side. This is the black side. And let's connect this up to my voltmeter. And we're going to plug in my voltmeter. I think it goes around that way. We'll find out in a moment. And I'm not having any luck here. My light is certainly not lighting up. Whereas we did have it lighting up a moment ago. Oh, I love things when they don't work. Yeah, so I've managed to prove that simply having a battery set up to a bulb, now it's working. No, it's not. Right, have I got a technical hitch with this bulb? Let's get a different one. Right, I've got my bulb working. I don't think it's going to work any better if I put another battery in, but we can try it. No, that battery, I think that battery has had it. So, I've got my light. Let's put in my voltmeter. And what we should have now is the light lights up. Yes, it does. My hand's in the way. So my light lights up when I press the switch, and we get something on the voltmeter, and we get something on the ammeter. Okay, so we've got a basic setup that we can look at various devices even if my batteries decided not to work. So I've arranged that there, hopefully so you can see things easily. And I've lost contact again. Being very simple, there's very little here in theory that can go wrong. But I certainly am having problems with my battery source. Let's go and change that to something else. Would you get me a power supply? So we're going to cheat now, and I'm going to go away from my batteries. Looks like they died on me, and we'll go to a mains power supply, and that hopefully will enable us to work better. So we've got a basic circuit. Let's see what will happen in this circuit if we can replace this with something like a resistor, and I've got a few different resistors that we can try. Lovely. So we're just going to bring in a DC power supply. It will work in exactly the same way as the batteries. I just didn't really want to use it because batteries look better. So let's set this up. I've got it fairly low. And if we set this up to about 3 volts coming out. I do have a problem with my circuit. There's something wrong here. We'll make the circuit really simple. We've just got a bulb, and that's working nicely. Let's bring in the ammeter. It's probably just a dodgy connection somewhere. And working with an ammeter, there it's working nicely. And then with a voltmeter, it works perfectly. Don't ask me what the difference is, I don't know. Right, so we can look at the voltmeter, and we can look at the ammeter, and we can see what I'm giving out as opposed to what I'm actually getting through. Slightly different, and that probably means there's some sort of discrepancy between the two. Let's look at some different devices and see what happens. Last time we tried a resistor. Let's try a resistor this time. So I've got a resistor. Either I can use this as a fixed resistor, and when I put this on, the numbers there we can just read off. I can change this to a variable resistor, and this is where I need more fingers, so I can hold down my switch Now I'm going to cheat here. I'm actually going to bypass the switch in a minute, and hopefully if I move my resistor we can see the voltmeter and the ammeter change as I'm changing the resistance. Better way of trying to see this would be to put the bulb in the circuit with this. So let's now have the bulb. I've got no switch in here, but I can change the resistance, and as I change the resistance, so the bulb will change its brightness. So here I've got maximum resistance, and as I remove more and more coils from the resistor, then the bulb becomes brighter. I'm measuring the resistance here across this voltmeter, across the resistor, but I could take these off. I could measure it across the bulb, and we can measure what happens on the bulb. As I change the resistance, so we can see here the amount of current and the amount of voltage going through the bulb changes. We don't see so much in the brightness here. The brightness of the bulb is staying more or less as it is, but just moving this handle, and move it that way if that helps you to see. This is just coming, and the electricity is coming in here through this metal bar onto this coil, and the electricity then flows along there out. So if the resistor is larger, we're going through more of the coils, the bulb is dimmer, and as I change this distance down to get less and less number of coils, so the bulb gets brighter and brighter because more electricity is going through the bulb and less through the resistor, because we're changing what's going on. When I talk about electricity, what am I actually talking about? Well, if we measure what's going on here, the current is changing, as is the voltage, because I'm changing various properties of both. And the bulb is a particularly awkward device to try and play around with. And it's an awkward device to play around with simply because it changes its properties according to temperature. Let's get rid of my resistor and let's set up a circuit. Let's take the voltmeter out of the circuit for a minute, and what we're going to do is we're going to put the switch back in the circuit. I'm a great fan of having switches, and let's now see if we can see what happens if we put a diode into the circuit. Now I think I'm going to change my mind, and I'm going to show you the diode with the bulb, because the bulb's going to show you you've got some electricity flowing through. So let's connect up the diode. The diode's going to be connected to the bulb, and the bulb is going to be connected to a switch. There's the circuit. It looks a bit of a mess. Let's go and have a look and see what it would look like if I drew the circuit of this. So to draw this circuit, where I've got my power supply, and really it is the same as having the batteries, I've got coming out going to a switch. We've got it going from a switch to a bulb, and from a bulb to a diode, and the diode back. Here we can also put in an ammeter if we wish, and there's my circuit. If I want to, I can put the voltmeter across either the bulb or the diode. So back to the circuit then. We've got everything set up, and if I switch on, then nothing is happening. What happens if I turn the diode round? And now the bulb is lighting. So this is the version we've got on the piece of paper, that the diode is facing, allowing the electricity to flow from the battery to the switch, from the switch to the bulb, from the bulb to this side of the diode, and this way the diode works, allowing then the electricity go to the ammeter and then back to the battery, and we get something working. If I switch on, you can see the bulb lighting up. But if we switch the diode around, nothing happens, and the diode then stops the electricity flowing through. It allows electricity to only flow one way. We could try, instead of the bulb, we can try an LED. Now, LEDs typically require a resistor with them, and if we don't, we get some problems. So, positive side from my power goes to the positive side on the LED, and I'm going to take the LED and put it back to here, and if I put on some electricity, here we are, 3 volts going through, my LED is lighting up. If I turn the LED round the other way, this is now the negative side connected to the positive, it's the wrong way round. Then, just as the diode didn't light, or didn't allow electricity to go through, then this LED won't do anything, because it simply is a diode, a light emitting diode, and electricity can't flow, whereas it will flow the other way. And there's my LED lighting up. Now, one of the things we need to look at is something about power and electricity. So this one is 2 volts max, so I'm going to pull my voltage down to 2 volts, and what I've got here is a simple thermometer measuring here 30, 35, 40, so on, and underneath that I've got a piece of wire, and we're only going to put 2 volts in, and let's see what happens. So I'm going to take my resistor and we're going to plug it in. I suppose the best thing we can do here is go and have a look at what the circuit looks like. So let's just draw that first. My circuit then, set at 2 volts. I've got my switch, which is closed, and then I've got this little resistor, and you can see that I'm not drawing it very well because I'm not using a ruler. Here's my resistor. Let's see what happens when electricity passes through this. So let's switch on. And I'm going to allow some electricity to pass through this resistor. It's already got up to 30 centigrade. And yeah, it's getting up to 35 centigrade. So this piece of wire is starting to get reasonably hot. So we've got to 30, 35, we're pushing now 40. So we've got up to 40 centigrade, and if I leave it a little bit longer, we may get up to 45 centigrade. Yeah, there we are, we're up at 45 centigrade, which is making this wire rather hot, and that's only 2 volts, 1.87 volts going through here. And we've got it up at 45 degrees centigrade. I'm going to switch it off now. And the wire will cool down rapidly. It's gone down from 45, it's cooling down from 40, rapidly losing its temperature, going down back to 35, and that's now safe for me to touch because that's the temperature of my body, so I know I'm not going to burn myself on it. So we've got some idea that as electricity travels through a wire, in this case a resistor, it's going to get hot. Let's undo that one. So electricity is going to get hot as we go through. And this is still just cooling down here from 30. So that's a property that we've got of electricity. I've tried to draw some simple series circuits. Let's try our charms at a more complicated circuit, and this one we're going to try our 2 bulbs in there. I'm going to go from the switch to a bulb. I'm going to go from the bulb to another bulb, and I'm going to go from the bulb back to the main battery source. Starts getting to be a little bit of a mess here with wires, and I'm going to put this back up to about 3 volts. And there we can see both bulbs light up. Not brightly, but dimly. To remind you, if I take this bulb out of the circuit and put that one in, this is what the brightness would look like. So bright with one bulb, but then when I put in a second bulb, we're seeing that something is happening. Perhaps we could say that less electricity perhaps seems to be flowing through them. Something is certainly different. I'm going to try and hold it so you can see it. What is different? Well, it's probably the current. So let's look at trying to draw this circuit out. So I've got the electricity going to the switch, to the bulb, to the other bulb, into an ammeter and back again. I'll draw the circuit so you're happy with this. This circuit then consists of our two cells. We're going to the switch, we're going to a bulb, a second bulb, to the ammeter, and back again. So there's our circuit. What I'm going to do this time is going to look at the ammeter here, and then I'm going to place it in different positions, and I want to see what happens. So we've got going around the switch, the bulb, the ammeter. So this is position 1. Let's see what our result of this is. So I've got my bulbs. Hopefully you can see those. Let's light it up. And again, I'm having problems with my ammeter. It looks like it's my ammeter that's causing me grief today. There we are, it's working. Don't ask me what change I made. And if I light both bulbs up, they're lighting up dimly. You can just about see that one coming up dimly as well. And if we read the ammeter, 0.14. Let's connect this ammeter in a different place. So what I'm going to do is I'm going to unplug my ammeter, and we're going to plug the ammeter between the two bulbs. We'll look at the circuit. This time I'm placing my ammeter between the two bulbs. I'm going to label it position number 2, and we'll see what happens. And I have got a slight change here, 0.13. I wasn't expecting that. Let's now take the ammeter out. Between the two bulbs, I'm going to get the two bulbs back up again. And this time I'm going to put it between the two bulbs. Here's the bulb, other bulb, and the switch. I'm going to take this wire out, and we're going to connect the ammeter here, and I'm seeing something I'm not expecting to see. Yeah, look at that, it's barely going. Got bad connection on my ammeter, I think. .13. My bulbs are now the same brightness they were before, so I've just positioned the ammeter in a different place. .13. I could put my ammeter in this first position between the switch and the power supply. So I'm coming out of the power supply, I'm going into the ammeter and then into the switch. Let's see what happens here. First time I've actually got them round the wrong way. There's my bulbs, there's my switch, there's my bulbs both lighting up dimly, and my ammeter was reading 0.13. My bulbs now are much dimmer than they were. The only problem with this wiring is sort of, you can see my bulbs are now very much dimmer. Let's just make sure I've got a good connector. No, my bulb's still a dimmer and it's 0.12. So it looks like I've got a very bad connection somewhere in my equipment, causing me problems today. Because what I would expect, but blatantly what I'm not seeing, is all those values should be the same current. What I should be seeing is that the current is different. Let's put a voltmeter in here and see what happens. I'm going to take my same circuit, switch, I'm going to have one light bulb, two light bulbs, going back, I'm not going to bother with an ammeter, and I'm going to place the voltmeter either here, position 1, or here, position 2, or maybe we'll try it across both of them, position 3. Let's go and have a look and see what happens. So I'm going to take this ammeter out. I've got my voltmeter, and let's set my circuit up. So I've got my switch linked to my two bulbs. We can see they're much brighter now than when we got the ammeter in, and the ammeter shouldn't make any effect. Let's put the voltmeter across the first bulb, which is this one here. So if I put it across here, I've got 1.5 volts. We've got 3 volts in theory coming out of the machine, and I've got on here 1.5 volts across one battery. So across the first one, I've got 1.5. Let's measure what it is across the other bulb. So I'm going to take that one across the other bulb. They light up the same brightness as before. I am having problems trying to get the things to line up for you. So there they are, lining up as before. And our voltmeter, if we look at our voltmeter, is set at 1.5. Alright. Let's take the voltmeter, and instead of putting it across one bulb, let's have it go across two bulbs. So coming out of the switch onto this side of the bulb, going to the bulb, coming out of the other side of the bulb. I think I've got my wires around the wrong way. I have. And now when I switch this on, we get 3 volts. You can just about see on the voltmeter here, set at 3 volts compared with 3.02, which it says it's giving out. So my voltmeter seems to be behaving better than my ammeter, and if we put it across both, I get 3 volts. So here are my 3 values. What are we seeing altogether? In a series circuit then, when electricity travels round through the series circuit, we're getting the voltage being split. Let's look at this. So across each bulb, the voltage here is split, and because they're identical light bulbs, the voltage is split equally. But the current, in theory, should be the same. We can also build this with a series circuit, a parallel circuit instead of a series circuit. Let's look at this one to finish. Same battery source, but this time we're going to have this bulb going here and this bulb connected there. Let's see if we can draw this out with the circuit. For some of this, I think what we're going to do is we're just going to take the voltmeter out to solve any confusion. Ammeter out the way, and we'll start off coming with the switch. So here's my basic circuit. I've got my electricity coming to my switch. There we are, it's going to stay still. And then what it's going to do, it's going to come into my junction box. And it's going to come from my other junction box to the rest of the circuit. In this junction box, I'm going to put in my 2 bulbs, and I can connect either this one from the junction box to this one, and this one to the junction box. This is my basic series circuit, and the other one comes out of my junction box, goes to the other bulb, and we'll go from here to the junction box. Hopefully this gives you an idea of what the circuit looks like. Paul can zoom out so you can get a better view of the circuit. So out of the battery, into the switch. From the switch it's then getting split, and it's either going through this circuit or it's going travelling down and going through this circuit. Let's switch it on and see what happens. Well, both bulbs are lighting up brightly. This is a parallel circuit. This is what I would expect. If we put the voltmeter in across one of the bulbs, let's do the one at the bottom, then this should be reading about 3 volts. Is actually reading up 2.8. Let's plug it across the other bulb. And logic tells me this should be about 2.8 again. I'm going to try and come around the other way. And there we are, exactly the same, 2.8, connected this time to the other bulb, across the other bulb. So we've got here a circuit which is rather different. We've got a parallel circuit where the two lights light up the same brightness and the voltage is the same throughout. Now, since my ammeter's not working terribly well, I'm going to turn my voltmeter into an ammeter, and I'm going to replace the first wire with the ammeter. And we'll see what the amps travelling along are going to be. It would help if we used it as an ammeter. And there we are, I've got 0.3938 amps going in the bit of the circuit where both bulbs are. Now, let's take out the bit which goes to this bulb. I think I've got it round the wrong way. I have. And going just down through the route through one bulb is 0.19. If I look at the other side of the bulb, we predict that's going to be the same. So I'm just going to take this wire out, put the black wire back, and we're going to put it the other side. Move everything around to try and accommodate the ammeter. There we are, so you can see everything again. Switch on, and the other side of that, I've got it plugged round the wrong way, but it's 0.18. Let's plug the ammeter in somewhere else. Let's get my circuit back as it was. When we put an ammeter into a circuit, we basically replace a wire. So I'm going to replace the bottom wire this time with my ammeter. And we allow the electricity to flow through. We have a fundamental failure here. There we are. 0.18 again. Put it the other side of this bulb. I'm going to take the wire out again. Taking a wire out of the circuit and putting it in. Things don't seem to be quite as bright, do they, down on this bulb? It's not a good a connection. Let's just see if that makes any difference. There we are, a bit better. 0.18. And if I take it in one more position, here's my circuit again with no meter in. I'm going to take it this before the switch. So I'm just going to put it in here for the switch. And there we are, 0.37. Let's look at this. So in this circuit here, the voltage was constant. But both bulbs lit up the same brightness. But I put the ammeter at different positions. In fact, we put it before the bulb and after the bulb. And we found here that the current split. We had, in fact, up here, if I call this number 1, the current here measured in amps was about 0.37, and when it split, and we'll call this position 2 and position 3, then about 0.18, 0.17, it was around about that sort of difference. And what we can see is that, not quite in this case, but it should do, I've got some bad contacts. I think that's what's causing the problem. Then what we find is that these two added up together make the total. So where we've got the current not split, it's high, and where it's split, half the current, because the bulbs are the same, is going one way and half is going the other way. That's given us some idea about playing around with this, not using the electronics, which gave a very sort of square view of things, but I've tried it with wires and other devices, so you can see that it's really quite a mess, and you've got to try and work out what goes where and how real things are slightly different than the diagrams. Next time we'll have a look at a bit more electricity and what it does. So we've got other things more on thermistors and light dependent resistors. I just didn't get on to that one today, but I did the series circuits and the parallel instead. So I'll see you next time. If you enjoyed this, then please remember to subscribe, and I will see you same time next week. Bye bye.